might be different. All of you just use the addition property, the subtraction property, and the division property of equality when you solve those equations. Okay, and these other ones are things that we know. We just might not have said them aloud before or done them before. Okay, so first one we have is reflexive property. When we look at that word reflexive, what does reflexive kind of sound like? Reflex? Good. I'm going to go with reflection. Okay, it's kind of like a reflection. When you walk up to the mirror to see your reflection, who do you see? You. How do you know it's you? Because it's you. It's your reflection. So reflexive is like a reflection. It's something is equal to itself, which just sounds silly. Like A is equal to A. Five is equal to 5. Now, we don't generally use the reflexive property with equations. We're not going to use it today, but it's important to know. When we use the reflexive property, you can see it in this poster up here, is when we're given a shape, usually, and we need to just state for our reader, like, hey, look at this MN. It's part of the top triangle, and it's part of the bottom triangle. Even though it's part of 2 different triangles, it's the same length both times. Does that make sense? Kind of, a little bit. It'll make more sense as we keep working on this stuff, but that's where that reflexive property really comes in. We don't really say 5 equals 5, because we all kind of know that already. All right, next up, need one? You don't get one. People named Adrian don't get pieces of paper. Just joking. Hi, Miss Morelli, you're so funny. What? Rude. All right, symmetric property. What does symmetric sound like to you?
Symmetrical.
Symmetrical or symmetry. What are some things in the real world that have symmetry?
Mirrors.
Mirrors, yeah. How are mirrors symmetrical? What you see in the mirror is the same as you, right? What about an animal that has symmetry? Anyone? Starts with B, as in butterflies. Oh, butterflies. Good. If you cut a butterfly in half, one half of the butterfly is the same as the other. One wing matches the other wing, right? Okay, don't cut butterflies in half, though. So symmetric property means that if we switch sides around the equal sign, so we go to those opposite sides. So, for example, if I know 6 plus 1 equals 7, if I started with that, the symmetric property would tell me that I can say 7 equals 6 plus 1. I'm just taking those sides and we're switching them around. So if you want to color code that, you can. Grab some colored pencils or highlighters. So here I start with 6 plus 1 on the left side equals 7. And then we switch that around. Now we have 7 on the left equals 6 plus 1 on the right. All right? All right, next up, we have transitive property. Transitive property we've kind of already learned. We've learned it if-then symbols, and we learned it about the syllogism property, or the law of syllogism. Transitive is really similar to syllogism. I think it's transitive as like a travel. The travel property, or you can write syllogism here too. If you remember what syllogism is, that if A leads to B, that's our storytelling. Okay, so what we know with our transitive property is if A is equal to B and B is equal to C. If we know both of those things, we can come up with a new statement. So if I know Marie is in the same grade as Tyke, and Tyke is in the same grade as Yorman, what does that really tell me? Marie's in the same grade as Tyke, Tyke's in the same grade as Yorman, then they're all the same, right? And which ones did I not compare yet?
A and C.
A and C. I compared A to B. I said A to B are the same. I made that comparison. What's my next comparison I made? B to C. So the final conclusion that we haven't done yet, the one that we haven't stated, is which two can we now compare and say are the same? A and C. All three of them end up being the same, but our new statement has to be one that we didn't already write. And the one that's left over that we didn't compare is A to C.
In other words, if there's two different things share the same thing, so it usually means that they must be equal to each other. Does that make sense?
Mm-hmm. So sometimes in our brain, kind of like how Mr. Kwan said, if A is equal to B, and if we wrote this, this is not technically mathematically correct, so if you went and showed this equation to someone, they'd be like, this isn't an equation. They'd be like, nah. And you're like, nah, it's fine. If A is equal to B and B is equal to C, so they both share that middle B, really that travel idea is that we're starting at the beginning, the A, and we're going to travel to C. That's what this is saying, is that if A is B, B is C, A is the same as C. They both share that middle part, then they're both equal. Okay. This is how my brain thinks of it. Now, when I talk to the other math teachers, I don't ever write this down in front of them. Just kidding, I do, because I show them how I teach it. But when I write that down, other math teachers are like, an equal sign, an equation can't have two equal signs. And they're like, meh. And I'm like, meh, it's fine. This is what my brain does. Okay, just because that's what your brain does doesn't mean it's wrong. Just means that we have to figure out a different way to write it sometimes. So, just letting you know. All right, substitution property. If you have a substitute in this class, what does that mean if we get a substitute teacher? How many of you had a substitute yesterday? Anyone? What did it mean to have a substitute teacher? Yeah, you still have teachers. Can anyone be a substitute teacher?
Yeah.
Could my 7-year-old niece come in and be like, I'm the teacher today?
No.
No. So we can't just have anyone come in and be a teacher. What's maybe a qualification to be a substitute teacher?
College.
Yeah, college or an adult, right? Someone who's been in high school before. All right, can't be a 7-year-old coming in and being a substitute teacher. That would be, you guys, she would lead you all in a really cool art activity, but, and she does take away cell phones. She took away my cell phone when we were doing school, when I was playing with her. So she would take away all your cell phones, but that wouldn't be allowed. Okay, the same thing like on soccer. If you're playing soccer and you get a sub, you sub in for someone, and it's a forward, are you going to sub in your goalie for the forward?
No.
No. Who are you going to sub in for the forward?
The forward.
Another forward, right? Somebody else who knows how to play that position. So the idea here is it has to be an equal amount. It has to be something that is of equal value. You can't just switch things out and say, okay, well, you can't have this, so I'm going to put this there instead, right? Okay, in general, we use this substitution property when we're switching out values that we know. So instead of always writing 5 plus 7, like we did in the board over there behind Mr. Kwan. Damon did that for us. At that top part, when we wrote 5 plus 7, it got rid of that minus 7, and we left with 6x equals. Did we have to write 6x equals 5 plus 7? No, we rewrote 5 plus 7. What was 5 plus 7 equal to? 12. So rather than writing it out how we always wrote it, we're switching it for what it equals.
For example, if A is equal to B, you can substitute B for any equation that has A in it. Because they are the same. They share the same thing.
All right, next we have our properties of equality, which these are all things you learned last year. These bottom two are ones that hopefully you remember. Okay, these properties of equality have addition, subtraction, multiplication, and division. And really they say the same thing, but it's just what operation we're doing. Okay, what you do on one side of the equation, you must do on the other side. Okay, that's what really all these are. Addition property equality would be when you're adding to both sides. So if you have any equation and we do like add 7, that would be our addition property. If we had something equal. Subtraction property would be if we're minusing on both sides, so like minus 5 on one side, minus 5 on the other. What would multiplication property be? You multiply both sides, like times 2 times 2. If you do it on one side, you have to do it on the other side. And then division property, we're dividing. Now, normally when we do equations, you can either use the division symbol, like the line with the 2 dots, or our 2 example people today, how did they show division? The fraction, so like divide by 3, divide by 3. I just came up with numbers there. You can use any number you want. Okay, last one. Distributive property. What does distributive property tell us?
Times whatever is in front of it and parentheses.
Good. Whatever is in front of it, we multiply by each part in the inside. So in letters, if we just do this algebraically, we would say A parenthesis B plus C. And we would take that A on the outside and go pew, pew. I always make that sound effect. Some people, they know this is like the rainbow property because it looks like you're drawing a rainbow. If you had me last year in algebra, you remember that pew, pew, because it makes me happy. And my happiness is the most important thing. That was a joke. It's not. All right, A times B would be AB. We keep whatever's on that in there, that plus, but we can't just do A times the B, otherwise we wouldn't have those parentheses. I'm doing A times the whole thing, so I also have to do A times C, so AC, good. Okay, so for example, what we did in our warm-up here, we had 3, parenthesis, 2x plus 4. That was in our warm-up equation that we had Hanan do on the board up front. She did a very nice job drawing those arrows. Both the arrows come from the 3, so it goes 3 to the 2x, and then 3 to the 4. Goes both from the 3. All right, if you like to, if this is still a tough concept for you, if you can say this and in your head you know it's just 6x plus 12, just write that. If that's something that you feel really confident in this distributive property, that's fine. I'm going to show one more step just for some of us that maybe need that extra little bit. We're going to write this as 3 times 2x. And we're going to write it as 3 times 4. So that way we know where we're getting our answer from. But again, if you already knew how to do that, you might just write the answer. So what is 3 times 2x? 6x. plus 3 times 4? 12. All right, eventually we're going to glue this in on your page. So I'm going to actually go to the next page. I'm going to skip a page because I'm going to glue this in eventually to this page. If you don't want to skip a page, that's fine. You'll just have to glue it in on the next one. So I'm actually going to skip over to my next page, the one next to it. I'm leaving this page blank so I can glue this in. And then I'm going to write my problem, my example over here. We're going to just do one example all together because we already solved 2 equations today. And then there is a 3-question assignment today. 3 questions? Miss Morrell, that's crazy. I know. It's wild. All right, so here's our one example. We're going to say if. I'm going to zoom in here. And anyone need this yet? Happy Coffee, why don't you do this with us, and then I can give you this later to copy. Okay? All right, if 36 equals 3 times 2x plus 4, then x equals 4. So remember, this is called what kind of statement? An if-then form. What's the official word for an if-then statement? Conditional. Good, conditional. What's our hypothesis?
X equals 2, 3.
Yeah. The equation, right? Good. You got it. So if the hypothesis is this equation, that means we're going to start with that equation. What that tells us is then, eventually, we should be able to get that x is equal to 4, which we've already done this problem. It's pretty much on the board, right? Yeah. We'll get there. All right, so when we do this, we do a 2-column proof. So remember, columns go up and down. So when we do this 2-column proof, the left side is always our statement, which is kind of like our work. It's our what. The right side is always our reasons, which is our why. Up to this point in math, your why has just been showing your work. It's been actually just statements. Now we have to actually come up with reasons. We have to use this sheet of paper that has properties on it to tell us why we're doing what we're doing. Okay? So when we do this, we number it, so that way we know which part on this side matches with this side in case it gets a little off center. So you can either use numbers like 1, 1, 2, 2, 3, 3, but because we're dealing with numbers, let's use letters today. So we'll do A, B, B, C, C. So A. And then we'll have our reason for A. So what is our starting statement? What does this problem want us to start with? It wants us to start with our hypothesis. Good. 36 equals 3 times 2x plus 4. Eventually, on my very, very last step, I want my conclusion. So what do I want my very last step to end up looking like? X equals 4. Yeah. Okay, so we're going to just solve this equation, and in the end, our answer should be x equals 4. What's our reason that we wrote this equation down? Where did it come from? Yeah, it told us to solve it. It came from the problem. Did you come up with this one on your own? No. It was given to you. So this first reason is called the given. It's what information or what was the situation that was given to you already. You didn't have to come up with it. You didn't have to think about it. It was the problem.
So if you think about on Wednesday when we did the Uno game, this is exactly the same. Like you given a card at the start, so and then you have to explain the reason. So it's given. So eventually you have to find, you have to finish the cards, right? So for in this case, you have to finish the equation at the end where x equals 4.
Yeah, and when we did the Uno, we had that starting card. And then as we went, what were our reasons? Do you guys remember on Wednesday? Well, same color or same number, or that it was a wild, right? Okay, so now we have to use the rules of math to solve this. So for part B, we're going to start solving this. So we already did this problem. It's pretty much on the board. It might be a little bit backwards, but that's okay. What would be our first step in solving this equation? Distribute. We'd have to do that. Pew, pew. So I have 36 equals, what's 3 times 2x? 6x plus 3 times 4? 12. So now I need to say which rule or which property told me that I can go from A, that was my starting card, my starting equation, to now I wrote an equation, but really it's the same. Which property says that I can get rid of those parentheses like that? Good. We go back to our sheet here. And on our sheet, to get rid of parentheses, that pew is distributive. So underneath reasons, that's what we're going to write, is distributive property. Sorry, there's just a lot going on over here. All right, so this is distributive property. And I'm going to put prop for property. Is that okay? Because the extra 4 letters is too much. Just kidding. You can write property out if you want. A distributive property. All right, our goal is to get x by itself. So we take a look at that x and we say, what is the coefficient of the x? What is with that x? The 6. We always like to keep that coefficient together as long as we can. So I'm going to get rid of that constant. What's our constant here?
12.
The 12, the number without the variable. So how did we undo adding 12? Minus 12. So I'm going to put minus 12 right underneath there. I'm going to show my work just like how we did on the board, or how you did last year. We have minus 12 on one side, minus 12 on the other side. If you need to draw that little line here, you can, down the equal sign if that helps you. Just don't get it confused with this line. And we need a reason for that step. Every time we show work, we have to show why we did it. So going back to your sheet, look at your properties there. Which one of those properties said if I minus 12, that's fine, as long as I minus 12 to the other side?
Subtraction.
Yeah, subtraction property. And it's a subtraction property of equality. So I'm going to say property of equal sign, equality. How are we feeling so far? Making sense? All right, so part D here. What would I next write?
The answer.
Yeah, the answer. What's 36 minus 12? 24. Equals
6x plus 6x.
6x. And we could write plus 0, but we won't go in that in depth. We'll just leave it there because we all kind of get that part, right? Okay, so what do we call that where instead of writing 36 minus 12 equals 6x, we could have written that out again. We switched it out for the answer. Yeah, that's substitution. Okay, substitution. That's where we switch it out for the right thing. So substitution. And this is why we can't abbreviate subtraction and substitution because they both start the same. Okay, and again, it's a substitution property of equality. It doesn't say that on there, but it should. Okay, are we done?
No.
Nope. How do we know when we're done again?
When we get x by itself.
When we get x by itself or we get the conclusion. Okay, so E, my next step. How am I going to get x by itself now? Divide by 6. And you can either use that fraction line if you like to, or you can use this division sign. In Schoology, just with the way it's formatted, I have to use that division sign, so you're going to see that in your homework. That divide by 6, just because that's the easiest way to format it without it getting crazy. Which property is that says if I divide on one side, that's fine, as long as I divide on the other side?
Division.
Yeah, the division property of equality. Another way to do property of equality instead of doing prop and the equal sign there is by doing a P, and then for of, we do a lowercase o, and then an uppercase E for equality. P-O-E, property of equality. That's probably what you're going to see mostly if we abbreviate. P-O-E, property of equality. All right, our next step, F. What do we got now? The answer. What's 24 divided by 6? 4. And what's 6x divided by 6? 1x. Good. 6 divided by 6 is 1. Do I have to write 1x? No, we could just write x. So instead of rewriting it again as 24 divided by 6 equals 6x divided by 6, we just switched it out for the answers. What do we call that when we switch something out for an answer? Substitution. Now, is that it? We're done?
Yeah.
No.
What does our answer need to look like, our final step?
X equals 4.
It needs to look like x equals 4. Does this look exactly like x equals 4?
Yeah.
No?
What? This looks like 4 equals x to me, does it?
Yeah, but it's the same thing.
But we have to say it's the same thing. So we have to prove that it's the same thing. We have to use a property. So for part G now, we're going to end with our final conclusion statement, which was our then, this x equals 4. So it has to look exactly the same. Okay, it has to look exactly as what the problem said. So which property was that said it's fine to switch it around the equal sign? Symmetric.